good day. So today we're going to discuss another problem using slope deflection method, but this time we have a continuous beam. This is applicable for members with hinge or roller support at its ends. So as you can see from this example, we have a roller at the end here. So yung previous examples natin are both ends fixed, then the other example is fixed free. So what if the continuous beam has a roller at the end of the beam? It could be on the extreme right end roller or hinge, or it could be on the left extreme end. It could be a roller or hinge. So whenever you have a hinge or roller at the end or ends of the beam, so we could modify the slope deflection equation for that segment. Okay, so again, so we have two segments here, segments AB and segments BC. So the first step is to designate the MEM or the member end moments. So they are assumed to be counterclockwise. Okay, so this is the moment on AB, counterclockwise, moment on BA. Here is moment BC, counterclockwise, again counterclockwise, moment on CB. Okay, so as we know that the moment on CB is equal to 0 because that is at the end of the beam and that is a roller, and there is no external moment applied at point C. Therefore the moment CB is just equal to 0. Whenever the moment here is 0, okay, so the slope deflection method on this segment could be modified with this in such a way that the moment RH is equal to 3EI over L theta R minus psi plus fixed end moment on RH minus the FEM on HR over 2. Okay, so yung for this case, the R, the subscript R means it's the inner support that has moment value. So for this case, yung R is yung point B. Yung H natin is the outer support wherein the moment there is 0. And yung H natin dito is yung C. Okay? So let's have first the fixed end moment. Okay, so what are the fixed end moments here? For member AB, the fixed end moment on AB, since walang load, sorry, we have a concentrated load at the midspan. So that would be PL over 8. So as we have derived earlier on the previous discussions. Okay, so that is counterclockwise, so that's positive. So that would be 40 times L is 4 over 8. So that's 40 times 8 over 8. So that's 20, positive 20. Now, how about for the fixed end moment on BA? So on BA, on the right side, it would be clockwise. So negative PL over 8, again, because the concentrated load is at the midspan. So that's negative 40 times 4 over 8. So that's negative 20. Now, what about for the fixed end moment on member or segment BC? So FEM on BC is equal to positive WL square over 12 as we have derived before. Okay, so W is 5 kilonewton per meter. The length is 6 meters square over 12. So that is 5 times 6 square over 12 is 15. Positive 15. While for the fixed end moment on member CB, that would be negative WL square over 12, and that would be negative 5, 6 square over 12, that's negative 15. So these are the fixed end moments. Now, let us write the slope deflection equation. So let me write it here. Okay, so let's start with MAB. MAB, so that would be 2EI over L times twice theta A, the near point is A, plus theta B minus 3 psi plus FEM on AB. Okay, so simplify and substitute. We have 2EI over L is 4. Okay, theta A is 0 because this is a fixed support, so that is a rotation 0. Theta B is okay, walang may value, and deflection here is 0. Okay, so that would be theta B plus FEMAB is 20. Okay, so that is our first equation. So furthermore, this could be simplified as 2 over 4 is EI theta B over 2 plus 20. So let me call this as our first equation. Okay, now next, what about for MBA? For MBA, it's again 2EI over L twice theta B plus theta A minus 3 psi plus the fixed end moment on BA. Again, theta A 0, deflection here is 0. So what is left is 2EI over L. L is 4 meters. Then twice theta B, okay, plus FEM of BA, which is negative 20 minus 20. So simplifying this would be 2 times 2 is 4 over 4 is 1. So this would be simplified as EI theta B minus 20. So that would be our second equation. Okay. Now next, how about for MBC? Okay, what is MBC? MBC, that is the moment, this is the moment on the inner support that has the moment value. Tapos yung MCB naman is already 0. So how do we write the M? So let me write it here. The MBC. Okay, so the MBC would be similar to this because the other end is a 0 moment. Okay, so that would be, this would be applicable for that. Okay, so that would be MBC. So yung B natin yung R, yung H natin would be the C. Okay, so that would be three EI over L. Okay, what's theta R? Theta R is the first letter, so B, theta B minus psi plus, what is the FEM for RH? RH is BC. So the FEM on BC minus the FEM on CB divided by 2. Okay? So, siya yung naging equation natin. So, simplifying this one, substituting values, we have 3EI over L. L is the length of BC, which is 6 meters. Theta B, this is 0, plus, what is FEM for BC? Positive 15. Minus, what is FEM for CB? It's negative 15 over 2. Okay, so that becomes the equation. So simplifying it, it would be 3 over 6 is 1/2. So that would be EI theta B over 2. And what is this? So 15 minus negative 15 over 2. So that's 22.5. So plus 22.5. So this would be our third equation. So from this problem, we have now 3 slope deflection equation. So what's the next step? The next step, after having this slope deflection equation, is to solve for the equilibrium equation. Okay, so let's have equilibrium equation. Okay, so for the equilibrium equations, so diba alam natin na the summation of moments at B should be equal to 0. So that means the moment on BA, here what, this one, when added to the moment on BC, the sum of these two should be 0. So what is MBA? MBA is this. MBA is this. So we have EI, sorry. So we have EI theta B minus 20. So that is MBA. What is MBC? MBC is this one. Plus EI theta B over 2 plus 22.5. So should be equal to 0. Okay, so simplifying this one, so 1 minus 1 plus 1 half is actually 1 and a half or 3 halves. So we have 3 halves for theta B, EI theta B. Then minus 20 plus 22.5 is actually 2.5 equals 0. So from there, I could solve for EI theta B. And that EI theta B is equal to negative 2.5 transferred to the right divided by 3 halves or 1.5. So that is negative or negative 5 over 3. So negative 5 over 3. So that is the value of, shift store ko na lang siya sa B. The value of our EI delta B. Okay? Now, knowing that delta, EI delta B, substituting it back. So let us substitute EI delta B in the slope deflection equations. Okay, so what would be our equation? MAB or MAB, substituting EI theta B, this one. So that would be 1 half of negative 5 over 3 plus 2 is equal to this one, 115 over 6. Or that is positive 19.1667. That's kilonewton meter. The positive there, that means that the moment is 19.1667 kilonewton meter. Positive, that means counterclockwise. Okay, so it's counterclockwise. So I could now remove the sign and put the direction. Now how about for member BA? For member BA, again substituting that theta B minus 20, that's negative 65 over 3. 65 over 3 is actually negative 21.667. Or we could write this as, tanggalin ko yung negative sign. So 21.667, that's kilonewton meter. And the direction is negative, ibig sabihin, opposite ng inassign kong direction. It is counterclockwise, it should be clockwise kasi nag-negative. So ito yung tamang moment sa BA. How about BC? Moment BC is equal to this. So EI delta B divided by 2 plus 22.5. So we got positive 21.667. Positive, that means 21.667 kilonewton meter. Positive means that's correct, counterclockwise yung direction. So as you can see, MBA and MBC have the same magnitude but different yung direction, because the summation of moment at point B must be 0. So that validates this equation. Okay, and of course the moment at CB is equal to 0. Okay, so those are the end moments. Then after this, applying statics. So apply statics to solve the reactions, the support reactions. So doing that, I won't be discussing this anymore. It could give you the reaction at A, the reaction at B, and finally the reaction at C. Okay, so the answers there. Okay, reaction at C is 11. This is 11.3889 kilonewton, which is upward. Reaction at B is 39.236 kilonewton, that's upward also. And reaction at A, okay, so I wasn't able to solve this, so by statics you could I will make this for you to solve na lang. That's also kilonewton, which is upward. Okay, so these are the answers in analyzing continuous beam na merong support sa dulo na hinge o kaya roller. So we can use this modified moment slope deflection equation. Okay, so I hope you learn something about this sample problem. Thank you.